Okay, today we talked about the rational number system a little bit more, and we kind of took some formalized notes on it. So just to reiterate what we've been talking about the past couple of days, we have our natural numbers. That's the smallest set of numbers that we have, and that is our counting numbers that begin with 1. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. Those are your natural numbers. You could see a couple of fractions be classified as a natural number if and only if it can simplify down to a counting number. So for example, 40 over 4 is going to equal 10. Every time you see a fraction, that is a division problem. So 40 divided by 4 is going to equal 10. If I had something like 18 over 3, 18 divided by 3 is going to equal 6. So again, that could be placed as a natural number because it simplifies to a natural number. Whole numbers are going to be all of our natural numbers. And now they're also going to include the number 0. So if you think of a number line, your natural numbers begin with 1, and they would be like starting with 1, the right side of a number line. Whole numbers, now you're starting at 0 in that right side of the number line. Integers are whole numbers and their opposites. So again, all of our natural numbers and whole numbers are also considered integers. If we have positive 15, now we're looking at negative 15. Positive 49, the opposite of that would be negative 49, and so these are going to be your integers. So these are going to be some negatives and positives along a number line with no fractions or decimals yet, with the exception of fractions that could be simplified down to a natural number or an integer. Our rational numbers, the technical definition here is any number that can be written as a ratio or a fraction in the form a over b, where b does not equal 0. Couple things I want to point out here. The word ratio, any number that can be written as a ratio. You guys can think of that as a fraction, but I also want to use that word ratio because that is part of the number rational, or part of the word rational. The a over b, your a and your b are just numbers. So any number that you can write as a fraction, basically, the only qualification here is that b cannot equal 0. So your denominator can't equal 0. We'll go more into those details when we cover division, but you cannot divide by 0. Again, all of these smaller categories belong in all of these upper categories. So once something is classified as a natural number, it can be classified as a natural, a whole, an integer, and a rational. If something is classified as an integer, so for example, negative 10 is an integer and automatically also a rational number. Since a rational number is any number that can be written as a fraction, again, just to clarify, like an integer, we could take negative 3,255. If I wanted to write that as a fraction, I can put it over 1. 378, I can put that over 1. So that rational number system is going to start introducing some fractions, mixed numbers, and 2 types of decimals. So you're going to have terminating decimals and repeating decimals. Terminating decimals are decimals that are going to stop. So this is going to be your 2 and 94 hundredths, 16 and 75 hundredths, negative 2 and 4 tenths. All of those decimal numbers are numbers that you have your decimal point, you have some numbers afterward, but then they stop. Repeating decimals are decimals that never stop, but they repeat in a pattern. So there's some sort of pattern to the repeating. So for example, this 1.3 repeating, that 3 is going to go on forever and ever and ever. So it's not a terminating decimal, but there is a pattern that repeats. 0.9 repeating, that 9 is going to go on forever and ever and ever. So it's not a terminating decimal, but it has a repeating pattern. This could also be something like 4.1818181818 and so on, and that would be also repeating. So in your groups today, we also worked with classifying these numbers. So I'm gonna walk you guys through these really quick in case you were absent. 2039 is going to be most specifically a natural number. Because it's a natural number, remember that automatically means it's a whole number, and those two categories are also within the integer category, and all integers are also rational numbers. So 2039 is actually going to be a part of all four of those categories. 7 8/10, we have a decimal. All right, our decimals don't come into play until rational numbers. So the only category there that 7 8/10 fits into is the rational number category. -1/4 is also only going to be a rational number. It does have a negative, but that fraction can't be simplified anymore. So -1/4 is going to be a rational number. 85%, we haven't really talked a whole lot about percents, but percents can also be written as decimals or fractions. And so, for example, if we made 85% into a decimal, it would be 85 hundredths. We could write it as a fraction, 85/100. And so because we can write it as a fraction, it's a rational number, okay? 15 thirds, we have a fraction here. So we always want to ask ourselves if we can simplify the fraction. In this case, every fraction is a division problem. So 15 divided by 3 is going to equal 5. 5 is going to be one of our counting numbers, so that becomes a natural number. If it's a natural number, it's automatically a whole number, automatically an integer, and automatically rational as well. 6.18 repeating, that's going to be a rational number. And 0 is a whole number, which means it's automatically an integer, which means it's automatically a rational number. So the only category 0 does not belong in is the natural category. Over here, when we have to figure out if these statements are always, sometimes, or never true, rational numbers are integers. So when we look, actually all of these numbers that we just talked about are going to be rational numbers. And so when we look, all of them are rational numbers. So if we look at how many are integers, some of them are integers. All right, this one was an integer, this one was an integer, this one was an integer, but not all of them. There's some that are missing that checkbox. So if we wanted to say if rational numbers are integers, this is sometimes going to be true. Whole numbers are integers. So when we look back over here, okay, I look at the ones that I classified as a whole number, and then if I look next door, they also all were integers too. So whole numbers are always going to be integers, okay? As soon as you can classify something as a whole number, it's automatically an integer as well. Whole numbers are natural numbers, so working backwards, I have my ones that I checked off as being whole numbers, and if we look next door, a couple of them are natural numbers as well, but not all of them. So this one is going to be a sometimes. Rational numbers are natural numbers. Again, looking, we have some that all of these are rational numbers, and so if we look, a couple of them are natural numbers, but not all of them, all right? So this will be sometimes as well. And integers are rational numbers if we look at the ones that we selected as being integers. All right, here's an integer, here's an integer, here's an integer, and if we look, every single one of those is also a rational number. So integers are always going to be rational numbers. Those were kind of our notes that we took today. Remember, you can always use your notes on quizzes, so feel free to add any of this information into your notebooks, and have a great